Hello, my name is Mr. Chuna. Welcome to my study room. Today I'm solving objective questions 3, 7, 47, 48, and 50 of the 2025 WASSCE Core or General Mathematics paper written by Ghana. I choose to put these questions together because they appear under the same topic, statistics and probabilities. Before we start with the first question, which is question 3, we'll go back to state the applications of statistics in our real life. Just a quick introduction to statistics itself. So statistics involves gathering, analyzing, and then interpreting data. And in this process, we attempt to describe the data. We try, in the process of gathering and analyzing, we try to find if there are any patterns in the data. And then in making decisions, or before making decisions, we can try to model the data in different ways, including using a normal distribution at higher level. And then from the model, we can make informed decisions, as in examples of finding confidence intervals or hypothesis testing. Then we can talk about probability. Probability, simply put, is the chance or possibility of something happening. And there are different ways of determining probability, like using dice, tossing coins, spinning a wheel with various fractions or proportions of something happening. And these are ways of predicting outcomes. Then to explore the likelihood of something happening or measure the likelihood of something happening, we can also use the tree diagram. We can use probability distributions in higher levels. What are the real life applications of probability? Let's find those quickly. We start with a very good introduction here that statistics and probability aren't just for textbooks. They are the engines behind most modern systems. Here are a few ways they show up in daily life. And the first thing we'll look at is in risk management and insurance. Insurance companies are built entirely on probability. Actuaries use statistical models to predict how likely someone is to have a car accident or a health issue. This determines the price of your monthly premium so the company can cover claims while remaining profitable. The second application is in weather forecasting. When a meteorologist says there is a 70% chance of rain, they are using probability. They analyze historical data from days with similar atmospheric conditions to determine the likelihood of precipitation in your specific area. Let's go to number 3. Number 3 is in the area of medical research and testing. Before a new medicine is sold, it must go through statistical testing. Researchers use statistics to determine if a drug is actually effective or if the patient got better by sheer chance. It also helps doctors understand the probability of side effects. Another area is in quality control in manufacturing. Factories can't check every single bottle of soda or every single microchip for defects. Instead, they use statistical sampling to test a small batch. If the sample meets certain standards, they can be statistically confident that the entire thousands unit run is safe. Another application is in sports analytics. Modern sports rely on statistics to scout players and choose strategies. Coaches look at the probability of a player making a shot from a certain spot on the court or the statistical likelihood of a specific play working against a certain defense. And then in the last one, when it comes to application, we have finance and stock market. Investors use probability to manage their portfolios. They look at the historical volatility of a stock to predict future risks. Algorithms use statistics to execute high-frequency trades based on patterns that happen in milliseconds. All right, with applications out of our way, Let's go quickly to question 3, which reads that the height of 4 orange seedlings are 2 centimeters, 5 centimeters, 7 centimeters, and 10 centimeters. Calculate the variance. We'll start by saying that variance is the square of standard deviation. And we know that the formula for standard deviation is square root of sigma or summation of each individual value minus the mean, all squared over n. But then we said the variance, let's call it V, is the square of this. So the square and the square root cancel out. And we will have sigma xi minus the mean all squared over n. To be able to find this, let's go ahead and find the mean first. So the mean is the sum of all values divided by the number of values. So that would be 2 plus 5 plus 7 plus 10 over, we have 4 values over 4. And then this is 7, 14 plus 10 is 24. So that gives us 24 divided by 4, which is 6. So the mean is 6. And that means that our variance is going to be each of the values. So 2 minus 6 squared plus 5 minus 6 squared plus 7 minus 6 squared plus 10 minus 6 squared all over 4. So the variance will be equal to 2 minus 6 is negative 4 squared plus 5 minus 6 is negative 1 squared plus 7 minus 6 is 1 squared plus 10 minus 6 is 4 squared. Negative 4 squared is 16 plus 1 plus 1 plus 16. This is over 4. So let me delete that and do it again. So this is all over 4. And then V will be equal to 16 plus 1 plus 1 plus 16 all over 4. V will be equal to 16 plus 16 is 32, 33, 34. So 34 over 4. And we can check that with our calculator now. 34 divided by 4. 17 over 2. So we press SD to get a fraction 8.5. So this is 8.5. And from the look of the option, that is option C. You go to the next question, question 7. Question 7 reads that in a class of 42 students, 21 offer history and 28 offer government. If each student offers at least one of the 2 subjects, find the probability that a student selected at random from the class offers government only. The key fact from this problem is that the total members of the class are 42, 21 offer history, 28 offer government. And then it says that if a student offers at least one of the 2 subjects. So this is also another point. Each student offers at least one of the 2 subjects. That means that we don't have any complement. Find the probability that a student selected at random from the class offers government only. There are so many ways you can do this, but I would like to use a Venn diagram to do that. So let me sketch my Venn diagram quickly. Alright, so we have our Venn diagram. I use H for history and G for government. In answering the Venn diagram, it is important for us to start from the intersection. So how many offer both subjects? That is not given to us. So let's make that X. And then if 21 students offer history Then that include those who offer history only, and then those who offer both history and government. So since we don't know how many offered history and government, history only is going to be 21 minus those who offered both. And then government only is going to be 28 minus those who offered both. And like I said earlier, because of the statement that each student offer at least one of the two subjects, mean that there will be nothing outside here. And that also means that when we add the three regions, we should get 42. So that's what we're going to do now. So that means that 21 minus x plus x plus 28 minus x should be equal to 42, which is the total. In grouping like terms, 21 plus 28 is 49. And then this x and this x cancel out. We have negative x minus x equals 42. Adding x to both sides and then subtracting 42 from both sides, we are going to have 49 minus 42 to be equal to x. 49 minus 42 is 7 equals x. Therefore, x equals 7. So wherever we see x in the Venn diagram, we put 7 there. This is 7. And then this means that 21 minus 7 is 14. And then 28 minus 7 is 21. And when we put them together, 21 plus 14 is 35. Plus 7 is 42, which equal to our total. So we write there. And now the question is, find the probability that a student selected at random from the class offers government only. So let me say probability of, let me use G for government only, is 21 over 42, because those who offer government only are 21. And if you reduce it, you're going to get 1/2. And looking through the options, that is option C. Let's go to 47. So 47 and 48 are together, and it has a table which has the age and number of students. And the question reads that the table shows the ages of students in a class. Use the information to answer questions 47 and 48. And 47 says that find correct to the nearest whole number the average age of students. Well, this data is from a frequency table. So to find the average, let me use AV for average. We are going to do sigma fx over sigma f, where this is x and this is f frequency. So fx means we are going to multiply the f and then the x, and then sigma means we put them together and then over the total f. So average is going to be 3 times 13 plus, we are multiplying this together, that together, that together, that together, and that together. So let's go back and do our multiplication. 14 times 14 plus 13 times 15 plus 8 times 16, and then plus 3 times 17, all over summation of f. So you have 3 plus 14 plus 13 plus 8 plus 3. 3 times 13 is 39 plus 14 times 14 is 196 plus 13 times 15 is 195 plus 8 times 16 is 128. Then 3 times 17 is 51 over 3 plus 14, 17 plus 13, 30 plus 8, 38 plus 3, 41. So 41 here. And then we can just now put everything into the calculator. In fact, you can also put this in your calculator. It's the same thing you get, but I just decided to work it down. And be my fraction sign. 39 plus 196 plus 195 plus 128 plus 51. Then I bring the cursor down over 41, and that gives me 609 over 41. But the answers there are in whole numbers. In fact, the question tells you the nearest whole number. So we press XD to get 14.85. 14.85. And to the nearest whole number, this would be approximately 15. And that is option C. And question 48 says that what is the median? So the median is the middle number when the numbers are arranged in order, either from the least to the highest or vice versa. Let me add quickly that these ages are already arranged in order, okay? But if we should list them instead of organizing them into a table, we are going to have 13, 13, 13, because we have 3 of them here. And then we're going to have 14, 14, 14, 14 of them. And we're going to have 13 of the 15, and then 8 of the 16, and 3 of the 17, right? So using that idea, we want to find the middle number if they were listed, okay? And from a frequency table, we can use the formula median equals 1/2 sigma f plus 1/2 position or number. So using the sigma f which we got here, 41, it means that you're going to have 1/2 of 41 plus 1 position, which is 1/2 of 42 is 21st position. So that means that if we listed these numbers, we're going to be counting until we got to the 21st number, and that's what we'll be doing. So this is 3 plus 14 is 17 plus 13 is 30. That means from 18, 19 all the way to 30, the number we have is 15, and we're looking for the 21st position. So already from 18 all the way to 30, we'll be counting 15. So the median is 15. And from the options there, that is option B. Let's take the last one, which is question 50. Question 50 reads that a fair dice is thrown once. Find the probability of obtaining an odd number or a prime number. So we'll start with the sample space. When you throw a fair die, what are the likely outcomes we should get? The die has 6 faces, and the faces are represented by the numbers 1, 2, 3, 4, 5, and 6. Alright. Now, they say it's thrown only once, so this is the sample space. And then the probability, we have to find the probability of obtaining an odd number or a prime number. Okay, so let's get the set of odd numbers from these numbers. Odd numbers are numbers that 2 cannot divide without a remainder, or numbers that when 2 divide there's a remainder, right? So we have 1, 3, and 5, and that's what we're going to put here. So 1, 3, and 5. Then let's have prime numbers. Prime numbers have only 2 factors, 1 and the number itself. And in this case, we have 2, 3, and 5. So the prime numbers here are 2, 3, and 5. Right. Let me add quickly that the probability of getting odd numbers, probability of odd, is the total number of odd numbers. We have 3 of them over the sample space, which is 6. Then the probability of getting prime numbers is total number of prime numbers, 3 over the sample space, which is 6, right? Now we go to the question. The probability of obtaining odd, let me use odd or prime, is the same as probability of odd union prime. And we are going to use the addition rule of probability, which says that if you have two sets A and B, then the probability of A union B is probability of A plus probability of B minus probability of A intersection B if they are not mutually exclusive, meaning that if they don't have anything in common. But when we look here, we can see that odd has the number 3 and prime also has the number 3. Odd have 5 and prime also has 5. So they have two numbers in common. That means that probability of odd intersection prime is 2/6, right? And plugging 1, 2, 3 into the addition rule of addition of probability, you're going to have A is the odd, so 3/6. B is prime, 3/6 minus the intersection, 2/6. And we can either use our calculator or we simply work it. They have the same denominator, so we repeat that. 3 plus 3 is 6, minus 2 is 4. And to reduce that, 2 will divide both of them to get 2/3. And looking through, that is option C. The probability of obtaining an odd or a prime number is 2/3. I hope this lesson has been of help to you. If yes, then see you in the next one. Bye-bye.